So yeah, population growth takes off on an exponential curve, and we have in fact passed the elbow of that curve. Here's a graph to demonstrate what the world's population is doing, and you'll see what I mean. Well, that's a problem, isn't it? Because it means we run out of food, we run out of clean drinking water, and facilities and all kinds of things begin to go wrong. So what can we do about that? Just stop having babies? Good luck talking anyone into that. It's really difficult. Ask China. It causes problems. But luckily, there are other things in our world that grow according to an exponential path. And one of them is technology. You may have heard of Moore's Law, which says that the amount of computing power we can fit in a certain space doubles fairly rapidly. Well, we've actually held to that rule for some time now, but we may actually even be surpassing it. It turns out that we may have gotten that exponential curve a little wrong, and it may actually be growing a little faster than we thought. Exponential growth is the reason we have Siri right now and Watson winning games on Jeopardy rather than just those old cell phones we used to have with antennas and maybe a few extra buttons on them. Things are changing really fast. Have you noticed? I understand that the iPhone 5 is going to debut this summer, and there will be a newer, updated version of Siri on that phone, and she'll be a lot smarter than the Siri that is trying to get Samuel Jackson to make Hotspotcho. Okay? Technology increasing on an exponential path is good for us because it means that we may be able to come up with technological solutions to some of the problems that our exponential population growth causes. For example, here's a graph that shows the relative intelligence compared to various life forms of the computers we've been able to build recently. And you'll see that it goes on and projects maybe where we're headed. Check this out. So if that continues, eventually you get a computer that is as smart as a human being. But it doesn't stop there. Then you get a computer that's as smart as two human beings and four human beings. And pretty soon you've got a computer that's as smart as a whole town full of human beings or a whole planet full of human beings. And that scares the bananas out of some people. Not me, because I actually think computers will be our friends since they'll kind of owe us a little bit. And maybe they'll help us solve some of these problems that we're not smart enough to solve. I actually think it's good news. But exponential growth is scary, and as I said, we have a tendency to want things to stay nice and smooth so we can make predictions and allowances and behave like everything's okay. Why do I bring this up? Well, if you've been a math student of mine in the past, you've heard this lecture before. This is nothing new. But I actually think it's really relevant to a lot of issues in our world today. One of them popped up this morning. This comes to me by way of the Scientific American blog. What I found out is that in North Carolina, which already has a bit of a spotty record on legislation lately, let's be honest. North Carolina, come on. Come on. Well, North Carolina has a problem. It has the same problem that most coastal areas have, which is climate change. Now, we would like it if the climate was changing along a linear path, but it's not. It's changing along an exponential path. Maybe not as sharp as the ones we've been looking at, but it is absolutely an exponential path. It's kind of like an Oklahoma afternoon where all of a sudden in the fall or winter the temperature plummets. And you notice when it drops faster than usual, don't you? People comment on it. Oh, this is bad. And it feels like something disastrous is about to happen. Well, if our exponential model of climate change is correct, and we have every reason to think it is, North Carolina is in a bit of trouble because North Carolina, I don't know if you've looked at a map lately, but it has a coastline, okay? Along the exponential model, water levels along the coastline of North Carolina would rise by a meter, maybe more. That may not sound like much. I know a lot of people in America aren't used to the metric system, so it's about the height of your average doorknob. That doesn't sound like much, but it would cost North Carolina a lot of money if the coastline rose by a meter. It would flood most of the lucrative areas of North Carolina, and that's a problem. And everybody's been trying to warn North Carolina that that is a problem. Okay. Maine has listened to this. They're projecting a rise on the coastline of 2 meters by 2100, and they're taking steps to work around that. North Carolina had a different idea. North Carolina is much more comfortable if the sea level is rising along a linear path. And so according to House legislation, House Bill 819, if this bill passes, no scientist in North Carolina will be able to predict exponential growth in the level of the coastline. They could only use a linear model. They could only project that the water will rise the same way it's risen over the last century, which would mean it would rise about 8 inches. See the problem? Do you see the problem, North Carolina? Not everything in the world moves on a linear path. In fact, most things don't. Most things move on an exponential path. But rather than actually address the problem, North Carolina is simply going to redefine the problem and say, la, 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 it's going to be linear growth. Yeah, so that could be a problem for North Carolina over the next, let's say, 80 or 90 years. Linear growth versus exponential growth. Watch out for it. It's deceptive because along the bottom of that curve, it sure looks linear, and that's how we want it to be. So we make plans accordingly. But it starts to bend. Oops. Oh, it's bending, and we say, la, 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 I don't want to see it. There it goes. And what happens then is things can change so fast that there's no way you can possibly keep up with them. So think about that. Linear growth, exponential growth. It's a math concept, which is scary, but I think you got it now, and it's really important to keep an eye on the difference as you watch the news. Hey, I'm Carv. Thanks for watching. We will talk again real soon.